Welcome to 6.2, Solving Trigonometric Equations, Part 1. The first step to solving trigonometric equations is to decide if the equation is linear in form or quadratic. If it's quadratic, we are expecting one of our trigonometric functions to be raised to a second power or multiplying two different trigonometric functions by each other. If it's linear, there is only first powers of our trigonometric functions. So if it is a linear equation, we're going to isolate the trig expression. If it's quadratic, we're first going to set it equal to 0. Then we will try to factor. And if it's not factorable, then we will use the quadratic formula. Once we set it equal to 0, then we will either factor if possible or use the quadratic formula if not. And then we will set each factor to 0. In either case, once we have isolated the trigonometric function or we have solved each factor, once we set it equal to 0, we will then use our unit circle or triangles to figure out the angles. Sometimes we will need to use our Pythagorean identities by squaring both sides. Example 1. Solve 3 tangent theta minus rad 3 equals 0. A over the interval 0 to 360 degrees, and B for all solutions. Looking at this equation, we notice that tangent of theta is only in the first degree. There's no tangent squared, and there's no tangent times some other trig function. So this is linear in form, so we need to isolate the tangent of theta. First, add rad 3 to both sides to get 3 tangent theta equals rad 3. Now we need to divide both sides by 3. So we get tangent theta equals rad 3 over 3. Now we are ready for either the unit circle or triangles to find all solutions 0 to 360. Tangent of theta is positive in quadrant 1 and it's positive in quadrant 3. Because of the rad 3, that gives us a hint that it's going to be a 30, 60, 90 triangle. We could try our reference angle being 60 degrees and see if that works. With 60 degrees opposite the 60 is going to be rad 3, the smallest side will be 1, and the hypotenuse will be 2. So tangent of theta equals y over x, or rad 3 over 1, which equals rad 3. This did not give us the desired results. You could determine that it's then going to be a 30-degree reference angle, but let's take a look. If the reference angle is 30 degrees, then opposite the 30 is 1, our hypotenuse is 2, and the other leg is rad 3. Now tangent of 30 degrees equals 1 over rad 3. And when we rationalize the denominator, that gives us rad 3 over 3. Therefore, we know our reference angle must be 30 degrees. So theta equals 30 degrees is one of the angles that satisfies this equation. We know we should expect two solutions because tangent is positive in quadrants 1 and in quadrants 3. But we already know our reference angle must be 30 degrees. So therefore, we need to find this overall angle from 0 all the way to our desired angle in quadrant 3. So since this is 180 degrees, to find this angle, we have to go to 180 plus 30 degrees more. So this will be 180 degrees plus 30 degrees. So our other angle is 210 degrees. Therefore, our answer to part A is 30 degrees and 210 degrees. Both of these angles satisfy the original equation. Now, for part B, the general form for all solutions is each solution plus the period times n, where n is an integer. The period of tangent is pi, or 180 degrees. So we will take 30 degrees plus 180 degrees n, also 210 degrees plus 180 degrees n, where n is an integer. However, let's take a look. When we take 30 degrees and we add 180 degrees, we actually get 210 degrees. So we could just start with 30 degrees and add multiples of 180 degrees. So we add 180 degrees, we get to 210. Then we add another 180 degrees and we get to 390 degrees, and so on. 30 degrees plus 180 degrees times n and 210 degrees plus 180 degrees n is redundant. Our final answer is just 30 degrees plus 180 degrees n, where n is an integer. Please note that for part A, we're only finding all solutions 0 to 360 degrees. But for part B, we're trying to find all angles that satisfy the equation. And this is giving us all of the angles that are coterminal with 30 degrees and 210 degrees. So for part A, when we're limited to 0 to 360, we're only going to have a finite number of solutions, where for part B, we're looking for all solutions. So we will get infinitely many solutions. Practice. Solve the equation 2 secant x plus 1 equals secant x plus 3. A, over the interval 0 to 2 pi, and B for all solutions. Notice here we have secant x in two different places, but both secant x's are raised to the first power, so we don't have a secant squared in either case. So this is still linear. Now we need to first isolate the secant x. So I will subtract secant x from both sides to start. So really this is 1 secant x. So 2 secant x minus 1 secant x is just 1 secant x, or just secant x. So we get secant x plus 1 equals 3. Now subtract 1 from both sides. So we get secant x equals 2. Converting this into a cosine, we can use the reciprocal identity. Since secant x is 2, cosine x must be the reciprocal, or 1/2. Now we are ready to go to our unit circle or triangles. Cosine x is positive in quadrants 1 and 4. Since cosine is x over r, we know our x value has to be small, and we do not have a rad 2 over 2. So we are likely to have a 30, 60, 90 triangle. Since x is only 1, we need our angle to be big, so our x value is small. So we will end up with a 60-degree reference angle, or pi over 3. Similarly, we will have a reference angle of pi over 3 in quadrant 4. So the angle in quadrant 1 is just x equals pi over 3. We know we need our answer in radians since they were asking for the solutions in the interval 0 to 2 pi. Now, to find this angle in quadrant 4, what we need to do is we need to take 2 pi and take away pi over 3. Well, 1 pi is 3 pi over 3. So 2 pi will be 6 pi over 3. And now we can take away pi over 3. So we get 5 pi over 3. So our other solution is 5 pi over 3. Similarly, we could have just found with a 60-degree reference angle, we would have gotten 300 degrees and converted that by multiplying by pi over 180. Either way, we would have come up with that second angle as 5 pi over 3. So for part A, the two solutions in the interval 0 to 2 pi are pi over 3 and 5 pi over 3. Now for part B, the first step is finding out what is the period of cosine. So cosine has a period of 2 pi. Therefore, the general form is taking each solution and adding the period times n, where n is an integer. So we take pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n, where n is an integer. Notice that this time we do not have any redundancy, because if we take this angle, pi over 3, and add 2 pi, we will get back here to be coterminal with pi over 3. So in order to describe all angles that are coterminal with pi over 3 and all angles that are coterminal with 5 pi over 3, we need to list them both out. So all of our solutions can be described as pi over 3 plus 2 pi n or 5 pi over 3 plus 2 pi n, where n is an integer. I hope you enjoyed this video. See you next time.